Good afternoon, everyone, and welcome to another Big Data London webinar. Today, we're joined by customer loyalty and engagement platform Punchh as they tell the tale of their data transformation journey, moving towards a modern cloud data architecture. I'm Andy Steed, Content Director of Big Data London, and I'm joined today by Heng and Gaurish from Punchh. Hi, guys.
Hello.
And Ryan from Databricks. Over in the corner. Hi, Ryan. Yeah, so these sessions are designed to be interactive. Please send in your questions at any point, and I'll endeavour to put them to the guys after the sessions are finished. Just a point of housekeeping quickly. If you lose the stream at any point, you shouldn't, but if you do, just hit refresh in your browser and you'll jump straight back in. But without further ado, I'd like to get on our first presenters. So over to you, Gaurish and Heng.
Thank you.
Hello, everyone. I'll just get this up. So are you able to see? Okay, hold on. Okay, there we go.
Yep.
All good.
Okay.
Yeah.
So Shin, up to you.
Yeah, let's get it started. This is Heng, and me and with my partner Gaurish, we're happy to talk about Punchh's pursuit of data uniformity today with the audience. This is a short outline. We're gonna start with introducing Punchh and our needs for developing commercial data products. With that one, we'll introduce Punchh data platform, what problems we're solving, and what opportunities are ahead of us. And in the end, Gaurish will help us summarize our major wins. And here is Punchh. So what is Punchh? Punchh is a marketing and data platform. Our unique data pipeline is called a customer acquisition and a loyalty solution. And a lot of enterprise clients are using us to drive their customers from anonymous to loyalist. We right now have over 200 retail brands on our platform across over 70,000 locations worldwide, and we're powering over 125 million users on our platform. Punchh was founded in 2011 in San Francisco Bay Area, but now we have offices in Austin, Toronto, London, and 2 cities in India. Today, we'll share how Punchh harnesses big data technology to solve our scaled data silos and how we enable a consistent and AI-powered customer experience. So Punchh has a few different business pillars. One of the major ones is how we manage a customer lifecycle. Here is a hypothetical. It's an example with hypothetical character called Will Jones. So when we say we help our clients to manage their customer lifecycle, half of it, it's about, hey, how about, just tell me my individual customers, loyalty status, right? If you look at the screen, this person, Will, he's under silver, and he has been with the loyalty platform for 1 year and 10 months. And we know, and we can summarize, your historical spend and your spend frequency. And I particularly highlight 4 boxes regarding Punchh's machine learning model on forecasting their churn and the future spend, and also their food item affinity. So if you look at the top bottom left, we can easily figure out this particular person's favorite items. So yeah, we have 2 items there. Of course, we can figure it out for all the items on the menu, and there's a little score there. And in the real platform, the retail brands can actually sort it and also do some filtering to pick out what the favorite item you want to push a campaign with. And then if you go to maybe the bottom and a little bit on the right, we have a product line called Merlin, and we actually have a way to use predictive analytics to figure out what's your future spend behavior, and commingled with what your historical spend, which they can segment you into one of the buckets. For this particular customer, we put them into something called potential superfan. Yep. So yeah, what makes Punchh unique, and why do we need data products? Punchh is dealing with physical retailers, and in order for the physical retailers to stay profitable, they usually have a very lean marketing platform. A marketing team. Therefore, they really rely on us to provide speedy and high quality data analytics. So when we started our journey at the very beginning, we do a lot of like a consulting service. We provide a lot of reports to the customers, and then realize with time, hey, there are a lot of analytics requests are similar. A lot of them are already asking machine learning type of questions. If everybody is asking about the same thing, then the needs for us to commercialize a data product gets really high. On the left-hand side, we show four, examples of the data products we're building. That's, the first one, for example, is a sentiment analysis, pretty complicated sentiment analysis dashboard we built by using actually the latest, NLP models. And go all the way down, we have store analytics, we have A/B testing over there. So with these dashboards, we basically help answer customers' questions regarding, let's take a personalization as an example, right? They will ask us, hey, how much does personalization campaign help? Yeah, we can tell them through A/B testing, 10%, 50% here and there. The harder question that we're also going to answer is, what is the long-lasting effect? So long-lasting effect meaning, yeah, I know that right now. How about in 3 months? Those things, especially if you launch a suite of marketing campaigns, right? So those things get a lot harder to answer. And with Punchh platform, which our data, and we are able to, of course, a lot of economics, we are able to answer those questions one by one. And one unique property that Punchh platform must has is called robustness, right? We're a B2B company. We're building products for our enterprise customers. So we have to figure out data solutions that is robust and solve all these challenging questions holistically. One-off solutions will not work for us. Yeah, next slide. And then here is our needs to build a data platform internally for Punchh and also directly for our clients. So, data platform, if you really summarize it, still going to be ETL, collect data, transform data, and then there's a different L. This L is leverage, meaning how we build a product around it that can bring in business value. So within Punchh, we have a larger variety of raw data assets, email, mobile, transaction, campaign, quite a few. And we try to organize them into a few very important pillars or say cubes: customer-driven, store-driven, or something else-driven. And what is important for us? Of course, the first one is speed matters. We try to set up a data platform. We understand that it's not easy. So we want to really be able to speed up a data pipeline, with easy maintenance and in the low cost. The second thing, actually, it's from a data property-wise, we definitely chase uniformity. What is the uniformity? Is two sides. First is technology. We try not to, every company, I think it's a bad idea to have, 25 different technologies on one core data platform, really hard to maintain. And also important to have pretty uniform data formats. I don't want to have CSV, JSON, zipped file, Parquet, Avro over the place. If we can consolidate, let's consolidate. And with the consolidate data technology and the data format, of course, the one as a data company we have to emphasize is, hey, data hopefully not self-complete. With all this technology uniformity, actually making data to not self-complete actually gets also easier. And the third point is stability matters. Prefer to have vendors, like Fivetran and Databricks with very stable roadmap and also great vision, which means that as a company like Punchh, we can rely on our partners to continuously build out great data products, and which also are aligned with our roadmap. And last one, which is also getting very necessary these days, is being cloud native, meaning we can plug into Fivetran or Databricks software into our platform in no time. Yep, next slide. So this is a high-level architecture of Punchh Data Lake. Data Lake as a term has been there for at least 10 years. It's nothing new there. It's all about how we use the technology to organize our data and what technology we are leveraging. So on the left-hand side, we have a lot of raw assets, auto production, mobile, and email. And we rely on Fivetran, especially Fivetran these days, to build a speedy and a stable data pipeline to pour our data into our data lake. Our data lake is being set up into bronze and silver. At this moment, we're doing some migration, but very soon, the entire data lake was solely based upon Databricks technology, which is called Delta Lake. And we follow the, Databricks nomenclature. Bronze Lake is about hosting raw data. Silver Lake is about hosting, process data and where products and analytics products can rely on. We actually skipped the Gold Lake of the Databricks nomenclature. For me, if we have Silver Lake there, that's the real data assets. And then the product team and engineering team can utilize the Bronze and Silver Lake to build, either data products, machine learning products, or any product that needs, accurate and a high volume of data. And we also are collaborating with enterprise customers to directly utilize our Silver Lake so that they can run their own advanced analytics. And also we can easily collaborate on doing, at least analytics or model developing together. And because we have, a uniform data asset, we kind of share the same data nomenclature, a lot of collaboration is also getting a lot easier. Yep.
All right, so now talking a little bit more about like the tools that we use to realize our data products and the real lake vision. So first is Fivetran. As some of you might already know that this is a tool which allows you to move data from one source to another. We use heavily within our infrastructure. So primarily, currently, if I go back to the previous slide, these are like our raw assets. So we have data in our production databases. This is typically MySQL, and then we have some mobile data, there is email data, and then there is vast variety of like third-party data sources. And what we do today with Fivetran is that it allows us to move data from our main production MySQL systems into Snowflake. And it allows us to do that with like a consistent data ingestion and high availability. And the setup is fairly easy. There is a web interface where you kind of set up the destination and then also set up like a source. And then I'll come on the cost-effective part on the next slide, which is also pretty interesting. And what that allows us to do is have our data available in like two sources, because typically the way any architecture will begin is that you will have like a database, you will have a web server, but then as you start going into these data analytics products, you will realize that, okay, what an OLTP versus an OLAP are kind of different tools. So what Fivetran allows us to do is move data from like our transactional store to the analytical store. And then on the other side, Databricks for us is like a platform wherein all our analytics, once we get the data into the Bronze Lake, after that, Databricks, we can run jobs and say that, okay, this is all I have to do to make it into a Silver Lake. And it's essentially a pretty good platform. And now coming up into like why we use Fivetran or Databricks. So just so you guys also know, Fivetran is not like our first vendors. Before that, we started our journey by like as any startup would, we tried to build it ourselves, but we realized that our time is more valuable by instead of just solving our business problem rather than trying to do an ETL do. So we went to the market, bought a tool called Illuma, which was now acquired by Google. And Google essentially then used that tool. So it was pretty good, but there were some deficiencies in how the architecture works compared to Fivetran. Like, for example, in the previous tool that we're using, all the transformations were part of something which will run in Snowflake, which would meant that it will inflate our Snowflake bill. So at one point, I think we were spending close to, I don't know, like $500,000 or maybe more than that on just our Snowflake spend. And then once we went to Fivetran, we were able to reduce that by 60%, which is a major win. And that is something that we really like. And apart from that, the one thing we also like more about Fivetran is that the overall stability compared to, let's say, the previous tools we have tried, it breaks left often. And so that's the part around Fivetran. Now coming on to Databricks, one of the big things coming from in my company, I head the DevOps team and I'm responsible for the infrastructure. One of the things which I really like about Databricks is that it reduces reliance on the infrastructure team. So if you guys are in a mode where you do not have a big DevOps team, or your DevOps team has other bandwidth constraints where they're not able to help you fully, or the other things. One of the things which Databricks allows you to do is, since it's a pretty much self-run platform, you can go ahead and run things without much of environment from your DevOps team. So in this case, Shane and his team can go and work independently with very little involvement from our side. Obviously, we will be there if things get stuck, but mostly you can work in a self-serve manner. And yeah, so this is what we all had to cover. So yeah, thank you.
Perfect. Thanks. Thanks, Gaurish. If you don't mind, just unsharing your screen just for a second. And however, in the break between the sessions, I just wanted to flag up a couple of points before we hear from Ryan. So, firstly, if for anyone who joined the session late or would like to go over some of Heng and Gaurish's presentation again, or look at the slides, this session will be available on demand almost immediately. So you can just click straight back in and then review the sections of that you will want to go back over. Also, I'd like to raise your attention to the attachments field, which is in the bottom left-hand corner. There's a link to the next Databricks webinar that we're running with analyst Mike Ferguson, and so you can register for that if you're finding this one useful. There's also some Databricks case studies and links there for you to look over at your leisure. However, without further ado, I guess we'll bring on our second presenter. So take it away, Ryan. Thank you.
Cool, thank you. So bear with me while I handle the menagerie of screens. So I think my screen's up, which is
all good.
A pretty good start. So cool. So hello, my name's Ryan Simpson. I'm a partner solution architect at Databricks, and so what I've prepped for the rest of this session, so it should be about 20 minutes, is just to talk more about this modern cloud data architecture that we've just seen, thanks to Punchh, and really expand on some of the learnings that that we had at Databricks that have contributed towards that. And it's an approach that I think you'll think you recognize. As Chen said, data lakes are not a new concept, but there are subtleties in there now that are the differences between hitting the things that matter, so speed, uniformity, and stability, and then delivering that on the cloud as well. So I'd like to start by addressing what might be your first thought in a move specifically to the cloud, and I'll expand on that in a little more detail shortly, because there's either an all-up move to the cloud, or you might be moving between kind of cloud-like tech and cloud-native tech. But the goal here is to challenge some of the assumptions you're going to jump to that I myself have been guilty of running with. So there is a natural tendency to reduce the number of variables that you're changing as you're moving between platforms, and one way to do that is to de-risk by lifting and shifting. So you might make that more cloud-like by picking one system or one application that represents the majority of use cases, or maybe you'll take a slice through your end-to-end needs with the view of migrating that, and then you might want to take on the challenge to then right size to the modern architecture you wanted. And we've already seen how tech like Fivetran can allow us to replicate between stores, and then sort of service that with Databricks, and we'll see that in more detail very shortly. But lifting and shifting brings some challenges, and I suspect many of us have experienced this. So firstly, it always takes longer. It always costs more than you think, and it's more resource intensive. And this is because on the surface, the target architecture is similar, but it's invariably just different enough to require a slightly different approach. So if I think of some database engines I've worked with, they've got a flavor on-prem and a flavor in the cloud, but the backup mechanism is different. And it's not something we factored in, and our operational overhead crept slightly up, and then things change. And the thing that we suffered was basically project fatigue. So we achieved the immediate case of getting to the cloud, but then we lacked the motivation to actually switch to the new architecture. So people will also often lose sight of the original reason for migrating. So the original system may have been built for one use case, then it had additional workloads added to that it was never intended for, and we hit the sides or the limits of that solution as a result. So in taking that approach, it's really a reverse-looking decision. This sort of lift and shift approach, it just builds for what you had, not for what you want. And it doesn't future-proof your architecture for kind of new use cases or some of the new approaches. And again, I'm sure that will come up in discussion. So if we're not lifting and shifting, what are we going to do? So this is it is a ridiculously highly simplified diagram. And again, I will completely accept that you will have seen something like this many before, but what I'd like to do is talk around some of the detail behind it that has driven the Punchh use case and the Fivetran sort of Databricks collaboration. So we've split it into an interesting color scheme, I guess. We've got this sort of bronze layer at the bottom, a red layer in the middle, and then a blue sort of compute layer at the top. So the original intention of the data lake, is to grab all this data and make it available somehow, and we will expand, whilst recognizing that we're seeing a move from structured to semi-structured kind of assets with variable growth at any time between the two. So we heard about emails being an asset. In other use cases, images have suddenly become useful. In the middle here, and this is probably the first difference I would call out, and certainly one of the aspirations around data lakes, is this curated data lake. So, the original intention was good around data lakes. Put all your stuff in one place, provide a way of bringing of storing any type of data, and then bringing any compute you want to it, taking advantage of schema on reads. And the original kind of goal was to not have these wieldy clusters that were managing your compute and also serving your storage. But we know a couple of things. One, people ended up with wieldy compute and wieldy storage, and it was tightly coupled. And we also know that the complexities around orchestrating feeds and managing the tendency of big data to be kind of append only meant that we all took shortcuts of some description, optimizations of some descriptions, and we ended up with people dumping all their data in, which led to garbage in, garbage out, and then a whole bunch of spaghetti code, and we got to this proverbial swamp. So in many instances, the dream of the data lake broke down. And this is where this curated data lake is different. So it says we're going to use different phases for our data, and this was the bronze, silver, gold nomenclature. And during those phases, we're going to enhance both not only the quality of the data, so its domain integrity will be appropriate, but it'll actually change its shape as it goes through the system. So in the bronze layer, we look a lot like the original source system, but the goal for a data lake is to present a unit of collaboration where people can talk over the data rather than the format, and they should be able to bring any tool they want to do that. So what's changed now, and this was always the goal to try and get to, that I think we may have struggled with, is that the original dream of the data lake was to separate compute and storage. And by separating that compute and storage, we would also choose the compute that would match the task, not the data format. So it might be a bit of SQL for ETL, then Python, etc. for machine learning, but then also have capabilities. And how many times have you heard, let's merge batch and stream, and then run into some tech that is great at one but not great at the other. So we're at a bit of an epoch, right? So cloud brings highly performant and reliable storage, and if we choose the right framework, and by the right framework, it can be hosted in compute in my subscription, and it should be based on open standards. I've actually got a fighting chance of building this architecture out and delivering on the reliability and the performance and the collaboration goals of a data lake. And that's not the same as running open source Hadoop or a proprietary engine in VMs over storage. So we're also at the big data world's had a number of phases where it's recognized that delimited files aren't going to cut it. So incorporating technologies such as column store have meant that now we can rely on open standards but still get the best storage format for the analytic workloads, and still work in a reasonably kind of transactional way. However, code bases to date have had, because of the distributed nature of the compute, most frameworks to date have relied on us coding in for failure, failed jobs, managing consistency and concurrency, so multiple processes writing to locations. And your framework should just do that. And it should also abstract away challenges with the cloud, like eventual consistency in some storage providers. And that's where Delta Lake comes in, or Delta as the text. So it's an overlay. It brings the features of transactional semantics, but it leaves you working in Parquet. By transactional semantics, I mean CRUD operations. So that actually all those things that drove lots of complicated code bases and lots of technical debt now just become simple operations. So we have, if we think about sort of starting to bring this this layer together, we got Fivetran as a batch upload tool, so running automated data engineering pipelines, bringing data in from all our sources. So they have a plethora of managed sources. So they understand those native on-prem data engines and the target engines in the cloud, and they allow us to think in an ETL way. So a few years ago, ETL was a bad phrase because it wasn't a big data pattern. Whereas actually we want to think like we're in ETL, but have it behave like an ELT system. So I want to code in an ETL-like way, but have it deal with scale and append-only workloads without having to think about it or code it in. And that's where Delta comes in. So I mentioned it was an overlay technology. So it sits over your Parquet in your cloud storage, such as S3, Azure Blob, or ADLS. And being blunt, it allows you to run insert, update, deletes, and merge without breaking any big data patterns. So we're not doing it in place. We expose the same APIs that you're already used to using through Spark and Spark SQL, and it's already using a file format that you're familiar with, right? So it's Parquet, so completely open and easy to interchange between the two. Under the covers, all we're doing is adding a transaction log, and that transaction log does two things. It handles the concurrency, so Delta-aware processes. And to get to a Delta-aware process, it's just a case of changing the name from Parquet to Delta. Everything else remains the same. They will synchronize around that T-log, but we'll also track all the metadata so that you're always reading and writing to the right stuff. I'm kind of glossing over that element a little bit, but it makes it resilient to job failures. But because under the covers we're versioning, you get some added benefits like time travel. So this is all just happening in your cloud storage. It's just Parquet and a T-log, and you can mount any Delta-aware process over the top of that, sat in Spark. So you can bring your own compute over that data. So Databricks, our Spark engine, is highly optimized. It runs in your subscription. It's next to the data, and we'll see later there are goodies in there, like a collaborative workspace that means that data scientists, analysts, and engineers can work directly with the data, either from Databricks or from other tools that understand Parquet. All that without you having to do that kind of technical nose of laying data out for optimal performance. So that's great, right? But the reality is Databricks starts in the cloud, so you've still got to get your data in there. And the end goal is that curated data lake. But right now you've probably got an on-prem estate or distributed sources, potentially in other clouds, that all expose their own APIs. They have different accountabilities for the data that they're authoritative for, so they have different latencies. Each upgrade gram will be different depending on how you're running that. And that's really the beauty of the sort of Fivetran Databricks implementation. So Fivetran understands that target modern data cloud architecture that I've kind of waxed lyrical to, I guess. All of its data sources are pre-built and fully managed by Fivetran, and so they can deliver automated data integration. So you only have to worry about the things you need to worry about. The logical, what is the impact of the system you're reading from? It will understand how to tie into that system and deliver the fully automated data pipeline. Then once that data is in your storage, as a data or Delta Lake, as we'll now call it, you can then bring any compute you want. So, Databricks would be my recommendation, unsurprisingly, in this instance. But again, you're just working with Fivetran storage and Databricks. So just to flesh that out a little bit, I've got a little just a elementary diagram here showing the variety of connections that Fivetran is worrying about for me. So Salesforce, SQL, event hubs, event grids, and then any number of storage formats tucked down in S3. They're simply presented to storage in Parquet plus the T-log, so it is Delta. And then we're in that land of the familiar, which is just Spark. Or Spark SQL to drive this, this ETL process in an ELT fashion, taking advantages of the separate compute that that Databricks can bring for us. So how's Databricks kind of tying into all of this? So fundamentally, we're driven by this vision to unify data engineering and data science. So we have a layered architecture. At the bottom here, you can see the wave, the big data and business data there's our data lake. That is your storage, ADLS, S3, or Azure Blob. Then as we move into this enterprise cloud service, so what that is doing is managing ephemeral compute. So we call them clusters, but you You ask for a compute with a certain number of cores and a certain amount of RAM. The enterprise cloud service provisions that for you, deploys the runtime, and again, you aren't worrying about the fine-grained details of a cluster. You just know you're getting some compute with version of the Spark, and then the ancillary libraries that you need. Then you can, if you want, you can use your own IDE and just connect over DB Connect or our Databricks Connect or our own API, or we have a collaborative workspace. So it's a notebook-like experience that allows you to interact with that cluster. And the way I would position that is, if you're a data scientist, it feels like Jupyter for data science, and if you're a data engineer, it feels like Jupyter but for data engineering. So at no point do you feel like you're in somebody else's tool. It's something that you can use. But again, you're only worrying about the kind of the what you need. Databricks is provisioning it for you in your subscription over your storage, and that's it. It's all open standards. So to wrap up, the modern cloud data architecture that I've spoken to here. So I'm going to say truly uses cloud storage, because I think we've heard this story before. But what's been missing is the ability to intelligently provision kind of just the compute you need in just the shape you need, and to manage all that stuff that you used to do in the physical world, but have Databricks abstract that away. So Fivetran dealing with the technical knobs of integrating with on-prem and replicating into our target source, and then just laying Databricks over the top to deliver the kind of uniformity that's Punchh were looking for in their data assets. So that's everything that I had prepped for this sort of 20 minutes or so. So I'm good for questions. I'll hand it over there if that's okay.
No worries at all. No worries at all. If we could just get off the sharing the screen, Ryan, if that's okay, just so we can see everyone's faces. And I might actually stick my first question to Gaurish and Heng, actually, from their presentation. You mentioned taking resource away from your DevOps team, which is obviously a great benefit and stuff. But I was just thinking, if there's any sort of managers or heads of data watching here, thinking about this kind of technology, what sort of people do they need? What sort of skills do they need to have? Maybe character traits or something. What makes a good team member over in Punchh? Oh, I think you're on mute, Gaurish. Sorry.
Yes. So just to understand the question, is it about working in Punchh like DevOps team, or is it in the data team?
In the data team, really. Just dealing with this project, really. If anyone's thinking of embarking on a similar kind of journey, what sort of people do they need? What skills do they need?
So this one is for you.
Oh, sure. Yeah, I can talk about it. So in general, right, for data team, especially in the big data world, what skill sets they have to have, which is pretty common place now, is they're gonna be able to write code and understand pretty much all or most of the data technology. And of course, for the junior, data scientists, data engineers, they may, but then their aggression or their ability to understand and hop on a new technology is important. For the experienced ones, of course, if you know how to dealing with billion of rows, you know how to move data around, and we talk about data migration, right? That's of course still the key. This traditional, right? One thing actually I noticed actually is very important with Fivetran and Databricks is they actually abstract away a lot of things that we don't want to know, and now we really don't want to know. Because in a traditional team, yeah, you're saying you're lead of the data engineering, you're the, you still deal with a lot of admin work, because as what Ryan said, right, moving data around is not trivial, because your systems are not really uniform, or basically say the tool is not that easy to use. So now with all these cloud technologies, especially with all the great cloud software, we still do some editing for sure. You know, we move data around, we need to get approval, we need to click some buttons, but those buttons are not very easy to click. Maybe one person can do everything for you, focus on the admin part and approver part. And the most of the other data engineers and data scientists do not ever worry about that things anymore, so they can focus on their work. I mean, for data scientists, a lot of them is about data discovery and hopefully found some ways to build models to automate, right? And for data engineers, you know, very similar. They're focusing on building a very stable data platform, and yeah, it's yeah, that part is yeah. I think that's my summary.
Okay.
To add on to it, the things which I feel we also need in addition, since we are dealing with a lot of data, and we have these days, as we go about, there is a heightened sense of privacy around the data. So what I feel is that we also need to be aware of like the security guidelines, the compliance requirements that are there. So those are two also very important skills, because at the end of the day, you are handling a lot of data which is belonging to some other individuals, which is not yours. So you have to kind of treat it with, you're essentially, you have to kind of consider as your like a custodian rather than like an owner, and you have to be careful of what you do with it.
Yes. Yeah. No. Quite. No, thank you for that. I'll pose another one to you both as well, if that's okay. A really, like, general one. I'm guessing there's going to be some people on this call who considering doing, you know, having a setup like this, doing something similar themselves. That's why they're watching this. Have you got like one piece of advice, you know, for somebody starting out? You know, general advice, you know, perhaps a, you know, an obstacle that you think they might have to overcome or something like that?
From operations perspective, my advice will be do not try to build it yourself. If you have never done it before, do not try to kind of try to make it yourself. Go and buy products like which are available in like Fivetran, Databricks, or anyone that use there, because they will have spent considerable amount of time doing it, and they will be able to kind of guide you towards the journey. So that will be my advice.
Yeah, think about, my suggestion will be very similar. It's nowadays, you know, the technology gets complicated, the data formats get complicated, and if you have, especially for most of the companies, including even large companies, right, speed matters. If you want to get speed and use a good cloud or say data partner, and more importantly is, you know, when using, for example, Fivetran or Databricks, right? Databricks is using open source data format, which is very important because a lot of people worry about, you know, being locked in, right? But with an open data format, you have a chance to internalize some technologies later. But once you have a platform, use it, get you up to speed quickly, and get you start building products quickly. And then, you know, in the far future, if you have some other plans, since you're on an open source data platform, open source data format, so you are well better off, you know, with that.
Yeah, perfect. And I'll come to you now, Ryan, if that's okay.
Sure.
Yeah, obviously you work with a number of customers, you know, there at Databricks and stuff. When people are starting this, is there any typical, you know, kind of obstacles people face, or, you know, and how do they overcome them, rather than putting a negative slant on the question? I mean, you know, what do people find at the beginning, and then, you know, how do they overcome them and get to the sort of nirvana you were describing in the presentation?
I think Gaurish hinted to it really, and it's security. So it's typically when we're looking at a you know, getting some value from, or getting short time to value, the technology is pretty straightforward, but it's generally the first time an organization will have tried to put data in the cloud, and even now it happens more often than I'm prepared to accept in my stubbornness, I guess. So the reason it's a challenge is because it's probably the first time, you know, you'll generally have a a customer data team that has been able to work pretty much autonomously, but it's the first time they've ever pushed up against their security infrastructure or their security team outside of some import-export process. So the ways to mitigate that are to, again, the open standards is important, but it's also the kind of the value that Delta brings. So again, I thought Gaurish's point was really, really important. So being, if I look at GDPR, the ability to be GDPR compliant or demonstrate that you can delete data you shouldn't have somewhere is almost the kind of the pinnacle use case. Above everything else, above tokenizing, just the ability to prove you've deleted it is that kind of standout use case. And that is ironically built into, it's a core use case in Delta as well. So kind of aware I've gone a little bit all over the place there, but one, it's security, because it's the first time that a team has to invoke a process that involves more than just themselves, and then demonstrating they've got the tools to be able to meet whichever security process that organization is trying to understand.
Okay, and then I think I'll close things up with a question to all three of you, I suppose, in terms of, with this solution and stuff. What's the one thing you couldn't live without now that you have it? Or and for you, Ryan, this is what you hear from the customers that you're dealing with, I suppose. What's the key thing for you, having done this and getting success from it, Gaurish and Heng?
Yeah, can you actually answer a question in a different way? So I couldn't catch it.
Yeah, of course. Yeah, no worries. So now that you're working with Databricks and you're doing this way, what's the one thing that you couldn't do without? You mentioned speed a couple of times, I think. Is there anything other than that, or is that the key thing? Sort of speed and flexibility.
Yeah, sure. Let's see. Yeah, speed. Yeah. Speed. Yeah, I mean, yeah, but around that line, for example, one thing I really enjoy Delta Lake is let's call it flexibility, right? One thing is when people mention ELT, right, or schema on read, meaning, with Delta, I think if you know the Delta syntax, in the old days, you always have to define schema and do some stuff, right? It's, pretty rigid. Sometimes I don't really have a schema. Just want to push something through. And with Delta, you can, if you understand the Delta format, you have a way to load your data first into it as a Delta, or do not worry about schema first. And top of schema, there's another thing actually I want to highlight, which is very important, that my team is actually enjoy a lot, is doing data pipeline building or building data product, right? So oftentimes there are two things you do. One, sometimes you want to force a schema, right? Because you want to exit your code if some schema is just mismatched. Another thing is sometimes say, hey, I want to change my schemas. I'm sorry, I want to add a new column, or say, hey, I want to change this data format from float to double, right? And sure, you can do that. I mean, you can do that yourself. But with Delta, it gets easier, right? When you have a merge schema, you can do where sometimes, I mean, with merge schema meaning, if you want to change my schema, there's a way you can do it. They call it schema evolution. And by the way, everything is also called back compatible because there's a history there. Another one is sometimes, another thing is more conventional is if I want to force a schema, if there's a schema mismatch, I should exit my code and throw an error, which is naturally there. So basically, that's actually a huge help. I can't recognize, even today, right? I actually recognize that as the ability to basically being flexible on either schema enforcement and schema evolution. It's very handy. I'll say that way. I think that's, for me, is one of the things jumping out of my mind.
Yeah.
And then from my perspective, I feel that we have now all the building blocks. So we can essentially use those Lego blocks to assemble and solve our business problems. So that's one thing, having done this, is we will continue want to do, is that we don't want to build Lego. We want to solve the problem, but we don't want to kind of go and reinvent the wheels, essentially. So that's one thing we kind of is a learning, that we should kind of rely on the shoulder of giants, as to speaks, and all the problems that have already been solved, we should just adapt those and try to solve the problems which are something that nobody else has solved and move forward.
Perfect. And yeah, Ryan, what have you been hearing from the people you've been speaking to?
Yeah, so I would say a double thumbs up for Delta. So Gaurish's point, you don't want to reinvent the wheel, and data loading and engineering, consistent pipelines requires conceptually really straightforward. Implementation details are, there's a lot of code to make sure something is repeatable, reliable, and Delta will knock that down to one line of code, but you'll know under the covers it is doing the right thing for you architecturally at scale. So, and I can validate that. I've had a number of architects as I've sort of pitched the Delta Lake kind of vision. The number of architects, 3 in the last month, that have come up to me during the break and said, they know Parquet, they know what they're doing. But ever since they touched Delta, they wouldn't want to go back to that old world of doing everything by hand again. So for me, it would be Delta plus, and then obviously the Deadrich runtime, because that has accelerated so many MVPs. I can collaborate with a lot of my customers just by passing notebooks between us and a couple of files just to examine data and processes. So when I say living the dream, it's we are, to Gaurish's point, working through the actual problem, not the setting up of stuff and managing of code.
Perfect. Well, with that, I'd like to say a massive thank you to our 3 guests today. Great presentations, and I enjoyed the chat at the end as well. A special thanks to Heng and Gaurish, because it's very, very early where they are. So a Herculean effort for looking so together and presenting so well so early on in the morning. So yeah, no, really appreciate that. Like I said, do check out the attachments. There's some ones to support the presentations you've just seen. There's some links to join us on the next webinar too. And with that, I would like to bid everyone farewell and to enjoy their afternoons. So thanks very much, and it's goodbye from us. Thank you.
Thank you. Bye-bye.
Bye-bye.